Welcome everyone to the Hammond River Angling Association's Riverkeepers class. Today we will be learning about citizen science and water quality monitoring. What is a watershed? What do you think that means? A watershed is a region or area draining to a particular watercourse or water body. The Hammond River watershed includes all streams and brooks draining into it. Why do we monitor water quality? Can you think of some reasons why this is important? The number one reason to test is because we are worried about the future of good quality water. How do we know if things are really wrong? When you test weekly or monthly, you know what normal looks like, and that means you can know immediately when values are off and can spring into action. All water bodies are different. Even though brooks and streams may all be within the same watershed, each have their own individual characteristics, chemistry, composition, and wildlife, all of which can be affected by seasons, environmental processes, and other external factors. What differences can you spot between these two brooks that can be found within the Hammond River watershed? Flow, shade, vegetation, geology, size, width, depth, and surrounding land use are some of the differences between these brooks. Many water issues are invisible, but water chemistry can fill in a few blanks and help you determine when professional lab testing might be appropriate. Lab testing is expensive and time-consuming and isn't feasible for every body of water all the time. The Water Rangers kits that you will use today give general indicators for water quality and will let you know when you should dig a bit deeper or contact a local conservation authority like the Hammond River Angling Association to investigate further. Regular testing of water is very important. Regular testing gives us baseline data. Sustained, consistent monitoring is the best way to know when something goes wrong. If you document regularly, when something changes, you will know right away. Many of these are visual. Shoreline alterations, colors, and even smells are great ways to notice changes. But if you're not sure what normal is with proof, it is hard to tell the authorities. Our memories are unreliable things, so always record your details immediately and take lots of pictures. Water quality monitoring is important because understanding leads to connection. While most Canadians say they care about water, many do not participate in its stewardship. Modern society is busy, complicated, and confusing, and researching what water chemistry means is often frustrating without a science background. By educating people on the basics of water chemistry and water issues, we are giving them a chance to start understanding what's going on so that they feel that they can do something about it. When something is difficult to understand, you often feel disconnected. But once you try these kits, you'll understand the basics and be able to connect to your local water bodies. Water quality monitoring is important because it can create a community focus. Even though solving our water issues can be daunting, the people have more power to change things than they think. Every day, they are making sure that companies, individuals, and our governments are being held accountable for their actions and pushing for higher standards. When we work together, when the community cares about an area, it gets protected. Together, we can make great changes. So now we know why we test. Because we are worried about water quality for the future, to know when something goes wrong with our water, to create baseline data, to connect with our natural surroundings, and to engage with our community. So now let's look at what we are testing. When we talk about water quality monitoring, we mean that we are looking at chemical, physical, and biological characteristics of water. It is a measure of the condition of water relative to the requirements of biotic species. Good water quality means it can support more plant and animal life. Here are just a few examples of different types of species that rely on good water quality. Presence or absence of these organisms can indicate the quality of water. From the smallest fly to the largest moose and everything in between, we all need good quality water. There is a large range of different tests you can do to determine water quality. The kits you will be using today will focus on 5 different parameters: pH, alkalinity, conductivity, hardness, and temperature. There are different guidelines for different water uses. We use the Canadian Council of Ministers for the Environment, the CCME 1987 Guidelines for the Protection of Aquatic Life as a reference. Temperature is interconnected with other indicators and holds a large influence on water chemistry. Temperature also exacerbates problems. It can encourage increased bacteria and plant growth and can reduce the amount of oxygen in the water. It is important to test both air temperature and water temperature, as these are closely linked. Higher air temperature will result in higher water temperature. For example, higher water temperature affects chemical and biological processes for fish. Salmon require cooler streams and need water temperature below 22 degrees Celsius. What could cause higher water temperatures in the Hammond River? Overhanging trees and vegetation help provide shade, keeping the water cooler. Removal of these trees and vegetation near water can increase water temperature. Once these trees are removed, the stream banks will become weak and start to erode. Erosion leads to a buildup of sediment in the water body, making the stream less deep and less cool. Paving and boat launches or adding docks or other infrastructure can also add additional heat, called a heat sink, into the water body. Climate change is probably one of the biggest factors affecting water temperature. Warmer air temperature and less precipitation lead to a warmer water temperature. We will use a portable thermometer to measure air temperature and our conductivity meter to measure water temperature. The next test we do for water quality monitoring is pH. In chemistry, pH means the potential for hydrogen, and it is a scale that is used to determine how acidic or basic a liquid is. Solutions are classified as acidic or basic based on their hydrogen ion concentration relative to pure water. Acidic solutions have higher hydrogen concentrations than pure water, and basic solutions have lower hydrogen concentrations than pure water. Alkalinity is the buffering capacity of a water body, a measure of the ability of the water body to neutralize acids and bases and thus maintain a fairly stable pH level. The ideal pH level in water for most species is in between 6.5 and 9.0. Small changes over time can lead to more plant growth, less oxygen and higher temperatures, increased mortality, or increased stress on organisms. What could cause increased pH in the Hammond River? Carbon dioxide concentrations from the breakdown of organics and vegetation, wastewater runoff from mines, sewage, and agriculture, natural rock formations such as limestone, and acid rain. Changes in pH and alkalinity can all indicate a change in chemistry. For example, increased algae in a water body causes increases in pH because they are consuming all the carbon dioxide in the water. A spike in pH may indicate a growing problem. There's an optimal level for your water body, and raising that level could affect every living thing in that water. Hardness is another parameter that we test for. Hardness is the amount of dissolved minerals in water, especially calcium, magnesium, and sometimes iron. Changes in water hardness can increase availability of toxins, or it can have detrimental effects on fish osmoregulation, which regulates salt and water in the fish, and it also affects pH stability. What could cause hardness in the Hammond River? Natural rock formations such as limestone or gypsum, acid rain, or magnesium and calcium. We use test strips to test for pH, alkalinity, and hardness. The next parameter that we test for is conductivity. Conductivity is a measure of water's ability to pass an electrical current due to dissolved salts or inorganic materials. Note that salt water will naturally have higher conductivity than fresh water. Conductivity can be used to estimate salinity, and many fish species have limited salinity tolerances. Increased conductivity can indicate that pollution in the water may be present. What could cause an increase in conductivity in the Hammond River? Increased dissolved solids or mineralization caused by higher pH, sedimentation or erosion, rainfall events or spring melt, or pollution introducing inorganics into the water. A spike in conductivity over your normal readings could indicate the presence of inorganic dissolved solids like those found in pollutants. If you test near a sewer or overflow or polluted stream, you will often get higher values. When conductivity levels are too high, it can disrupt the normal functions of an ecosystem and may mean fish have trouble reproducing. Knowing your body of water helps too. We have one stream in the Hammond River watershed called Salt Springs Brook, and its normal conductivity levels are usually twice as high as the other brooks in the watershed because the water passes through underground salt caverns. Now that we know why we test and what we test, it is time to learn how we test.